So, here we are with chapter 3. This is page 1. We've got a function. This is a cubic function, and we've got to find all of the zeros. Well, I guess not all of the zeros because we have one of them already. Let's put in 3 as our zero into synthetic division. Well, the coefficients in our function are 1x cubed, 2x squared, negative 11x, and negative 12. If this works out, I should get a 0 here, because 3 is a 0 of the function, the remainder should be nothing. But let's get there. So, I start off, drop down my 1, multiply by 3. Add them together to get 5, multiply by 3 is 15, subtract 11 is 4, times 3 is 12, and oh look, it is a 0. So, this tells me I can factor this into x minus 3, and I decrement my exponent by 1. I have 1x squared, let's keep that in purple, just cause. 1x squared plus 5x plus 4. Guess I can take off this 1 because 1 times anything is just itself. And I can factor this. This is x plus 4 times x plus 1. Here are the other two factors. The other two zeros, if you want to say it. Zeros are negative 4 and negative 1. And that is all. You know, since that was so short, let's take on page 2 at the same time. So, f of x is 2x cubed plus 7x squared minus 48. And we want to know, is x plus 1 a factor? Well, one thing we can do is put 1 in here and see if we come out to, negative 1 in there. See if we come out to a 0. But there's an easier way, I think. Let's put in negative 1 into synthetic division. If it's a factor, we should be left with a remainder of 0. If it's not, we'll have a remainder of something else. We've got 2x cubed, 7x squared, how many x's are there? 0 x's. It's missing that term, but you got to include it in synthetic division. And negative 48. Let's start off by dropping down that 2, multiplying by negative 1. 7 minus 2 gets you 5. 5 times negative 1 is negative 5. Drop it down, multiply by negative 1 gets you 5. And I'm left with a remainder of 48 minus negative 48 and 5 is negative 43. So the answer is no. How far away is it from being a factor? Well, f of negative 1 is 43. Not only does it test if it's a factor, but it actually gives you what you get if you evaluate at negative 1. Let's take on problem number 3. If 6 painters can paint a wall of 1,200 square feet in 3 hours, how long will it take 10 painters to paint a 1,500 square foot wall? This right here is a variation problem. We've got some number of painters. We'll call it P equals painters. Take some amount of time, call that T, to paint some number of square feet of a wall. Call that W. Now, we're trying to figure out how long it'll take. So let's say the amount of time is equal to, and we've got some number K times, well, for every painter, that decreases the amount of time. In fact, if you have one painter, you add another one, that cuts the time in half. A third painter will cut the time again. A fourth painter will cut the time even more. So we're dividing the work evenly among the number of painters. Of course, as you add more wall space, that just adds more time for their work. You got to do more and more with more walls. That takes time. So we're left with some constant times the amount of walls over the number of painters. Now we've got 6 painters, so P is going to be 6. They paint a 1,200 square foot wall in 3 hours. So let's say 3 equals K times 1,200, all divided by 6. Now, I could simplify this. 1,200 over 6 becomes 3 equals K times 200, or 3 out of 200 equals K. That seems weird. But perhaps not. So, let's see if this makes sense in the context of our plugging it into our next problem. That it will take 10 painters, so now time equals 3 out of 200 times 1,500 square feet out of number of painters, 10. Let's cancel out our zeros. We've got 3 over 2 times 15 over 10. The amount of time it will take equals 45 out of 20. Or 2 and 5 more 20ths. Oh, I guess I could have simplified that. In any case, 5 20ths is a quarter. 2 1/4 hours to paint 1,500 square feet for 10 painters. Let's see, 6 painters, 1,200 square feet. You're almost doubling the number of painters, and you're taking just a little bit more of the square feet. Should take you a little bit less than 3 hours. This seems pretty reasonable to me. I think we've done everything right. If we haven't, definitely email me, because I don't want to mislead you. Alright, hope this helps, and enjoy.